take a look at this little plot of land. If we measure the length of one side, it might be 3 meters. Then we measure the length of the other side, and it's also 3 meters. So to find area, it's length times width, or a length times another length, and that's going to be 3 meters, but we're multiplying it by another 3 meters, so it's 3 meters squared. Now, when you write an area like this, you want to remember to distribute that square to everything inside. So if we square the 3, it becomes a 9, and then the m squared is just that. That is the area of this plot of land. Now, what if we have the area, which we know as 9 meters squared, and we want to know how many centimeters squared is that? Now, we've got to be a little bit more careful here because notice how our dimensions up top are single dimensions. So, as a reminder, you could also write 9 meters squared as 9 meters times meters. You could also write centimeters squared as centimeters times centimeters. That's going to be helpful when it comes to solving these types of problems. And just to extend it a little bit, if we had a problem that involved, cubic centimeters, just remember that that's the same as doing centimeters times centimeters times centimeters. So just remember how your exponents work. Let's start with what we know. We have 9 meters squared. I'm going to convert from meters to centimeters. And look at this. I can do that because I have a conversion factor here. So I'm going to put meters in the denominator, but there's something we have to note. This meters squared at the top, remember, we could write out as meters times meters, and I'm actually going to do that to show you explicitly what is going on when you have more than one dimension you've got to work with. I'm going to go from meters to centimeters. We know that 100 centimeters is inside 1 meter, but watch how only one of the meters gets canceled at this moment. We ought to keep going because right now we'd have meter centimeters if we stopped it. So go further at least one more step. We got to get rid of another meters, and we're still going to centimeters. We got to do it twice because we're going from a squared unit to a squared unit. So we still are going to put our 100 centimeters in our 1 meter here, but notice how now we finally got rid of the second meters. So we can circle both of the centimeters. Boom. That means that when we're done, we have a centimeters times a centimeters, and that's going to be our right answer. So when you do your math here, you get about 90,000, not just centimeters, but we have centimeters times centimeters, so it's centimeters squared. We went from an area to an area. And that's how it works when you have more than one dimension to think about. We have a 2-dimensional area, so you've got to be careful and make sure you're canceling out things multiple times. Let's try another one. This is gold, and the density, that's this Greek letter rho. Looks like a really sideways P. The Greek letter rho means density. The density of gold, no matter what size you have, is equal to 19.3 grams per cubic centimeter. Density is going to be mass divided by volume. So grams is a mass unit. A volume unit is cubic centimeters. But what if we wanted to express the density of gold not in grams per cubic centimeter, but instead as kilograms per cubic meter? Still a mass in the numerator position, still a volume in the denominator position, but we've got different units. So we're going to have to do a double conversion factor, or double dimensional analysis, so to speak. So let's see how that would work. We've got one thing we know already, which is 19.3 grams per every cubic centimeter. And remember, you only have to deal with one thing at a time. I'm going to deal with grams first. To get rid of grams, which is in the numerator, I'm going to put it in the denominator. And to go from grams to kilograms, I'm just going to go right to that part right here because we actually have a conversion factor. So we can put immediately in there that 1 kilogram is made up of 1,000 little grams. A gram is like the mass of a paperclip, and a kilogram is like a decent sized textbook. So we're going to cancel out the G's, and we can circle kilograms because that's actually where we're headed, and that's what we want. Our mass unit is already converted. Awesome. Now we got to deal with our volume unit, but we have it as cubic centimeters. So I'm going to go up here, and I'm going to deal with it one dimension at a time. Remember that cubic centimeters is just a centimeter times a centimeter times a centimeter, if that helps you to remember. So let's deal with one of those centimeters first. I can put centimeters up top and put meters in the bottom. We know our relationship here is 100 centimeters is equal to 1 meter. So this cancels out one of the centimeters. But we'd have to do that 3 more times, so let's do that. Notice how we have 3 centimeters that got canceled out. So now we have the entire cubic centimeters all canceled out, which is great. So we can cross out the whole thing. We can also get rid of this because we don't really need it anymore. And notice how we have those 3 meters in the bottom, but they're all going to end up being multiplied. So I'm just going to circle them. We want to keep all of them. Meters times meters times meters is a cubic meter. So now we can do our math. And we get an answer of 19,300 kilograms per cubic meter. It's just another way to express the density though. So that would be our answer. What if you don't want to write out all of those centimeters over meters, centimeters over meters, centimeters over meters? I'm going to show you another way that you can do it. Now that you understand that you've got to cancel out each one of those dimensions, here's a shorthand way to do it. Notice how we've got sets of these. So we've got multiple sets. We got this, we got this, we got this. It's the same conversion factor, just multiplied again and again. So we can actually put a whole cubed around it. So I can put a cubed here, which is the same thing as writing it out 3 times. The thing that you'd have to remember though, is that when you cube something, you've also got to cube that number. So let me get rid of these parentheses to show you what that means. If we cubed that centimeters here, we'd also would have to cube the 100. That's something that people often forget. So it's 100 cubed along with the centimeters cubed. Now, that does extend the fact that we could cancel out, the centimeters cubed here and the centimeters cubed here. And that just means that just as we saw, we had 100 times 100 times 100 in the numerator, we would just do 100 cubed, which is 100 times 100 times 100, with our math here. It's the same thing, but you're just doing it in a slightly more succinct way.